copied the first line.
Yeah, I did, so, sign. Should have just done it on the board.
Yeah.
It's a lot easier to do this when you're sitting at your desk, actually zoned in on this stuff. So we have sign times 10. Okay. Cosine times 5, 0 plus 10. Okay, that's good. And then we have
15, yep, and
0, 0, 15, 0, that's good. And then 0, 0. Okay, so there we go.
yeah, because the one that we did on number 2, we did the opposite multiplication. Instead of doing BC translation to position C, we have position C times BC translation. And that's what you have in your notes too as well, when we were going over it.
Now, let me see,
Why,
because I'm-
why are we switching it now? That's why I'm.
Let me see, okay, I'm not quite sure. So when we went through here, we went and put that guy first. Okay, so I think that I misinterpreted your work here because we should be taking the position vector expressed in C
This
after
was
the
off your
thing.
notes though. This is what your answer was. We had the same answers. That's why I'm confused now.
I don't think so.
Are your answers 2, 0, and 3 for position B? 2, 0, and 3,
Yeah,
and
but
3,
look at
2,
what I
3?
did. I mean, what I have on my problem number 2 solution is entirely different than the approach that he used.
Oh, okay.
I'm taking the transformation from B to C, just like I did down below, times the position vector in C. And so I have the translation matrix here times the position vector to get the resultant. Okay, and that's the exact same approach as I used down below. That makes sense?
Yeah, no, it does.
Okay. What's up?
And I'm just looking at it, how we got position A was because the translations for A to B and B to C would cancel the B's, and then the position C would
Exactly.
cancel the C's, leaving only A.
And that's one of the convenient things about this notation. As I've mentioned before, this notation can be somewhat cumbersome to use, but once you get a feel for it, it makes a lot of sense, because in this case, we see that the C subscript is canceling the C superscript, leaving us with a position vector expressed in B. Same thing down here, we have the B subscript canceling the B superscript, the C subscript canceling the C superscript, leaving us with a position vector described in A. Okay, and that's very, very useful for us. So, that makes sense? Sorry, I just shouldn't try to type these things on the fly like that, so. Any other questions real quick? So when you end up with your representation, you can see that what I did was I drew my frame A in black, frame B in blue, frame C in red. And then what I'd like to see is a representation to that position vector from one of the frames. Okay, in this case I expressed that position vector from all 3 frames just to demonstrate that it was pointing to the same location. But the fact is that if you just express the piece of C from frame C, that's more than adequate to satisfy the problem. Really what these 2 problems are doing is getting you into MATLAB and starting to work around with matrices a little bit to understand how to use them. This is based almost entirely off of the code samples that I have in the lecture notes. So, and then down below, when you go through and do your rotations, you can see that frame A is oriented, this is kind of small, I'll do the zoom in thingy again. Yeah, that's a little better. But in this case, what we have is frame A oriented at 0, 0, and then frame B with a displacement vector and a rotation. You notice that the orientation of that frame is not the same as frame A, followed by a subsequent displacement and rotation of frame C, and this then provides us the resultant vector with respect to frame C. Now, if you think about a typical robot, are we going to have these weird link twist angles? What are the link twists almost universally going to be? 0 degrees or 90 degrees, right? If you look on that robot, you do not see a single twist angle on there that's not 0 degrees or 90 degrees. They are all, either parallel to the existing axis or perpendicular to the existing axis. So we're not going to have these weird 30 degree or 60 degree or 120 degree twist angles. They're all going to be, or they're generally going to be 0 or 90 degree for a twist angle. The fact is we could manipulate these, but then that would make our motion planning kind of difficult, because then we'd have these weird links that just would be doing strange stuff in space. So, okay, so does that kind of help you out on the homework?
Yeah. I also had a question on number 7, because we really haven't gone over how we would do the multiplication process.
Let me go back and look at it.
How would you multiply those two together? Could you
Well,
just multiply
that's
them one
just-
way and multiply them the other way? Same thing?
Yeah, you just go row by column,
So,
And ultimately, what you're going to see is that when you multiply it this way, you don't end up with the same result as when you multiply it this way.
yeah, so we would do the cosine of theta times 1.
Right.
And then 0 times sine of theta is 0, 0. So row and column, so row the first one, column of
Yeah.
the second one.
So row by column,
Okay.
row by column, and so on and so forth. And when you end up, remember, and this is just your dot product of the row to the column in each case.
Yeah.
So what you see is that when you do that, you end up with a different result in the two scenarios, and the key to this question is explaining why there's that difference.
Do you have to do the multiplication if you can just simply explain why it would not work?
Yeah, if it's a good explanation, that's fine, so.
Well, yeah, it's just like saying, well, you're rotating and then you're moving, and then
Well,
another one you're moving and then you're rotating. So of course
And
it's not gonna be the same.
that's exactly what is going on there, so.
Alright, I was just wondering how do you have to do the multiplication?
Yeah, in this case, it's just the row by the column, all the way through the operations, and it's not particularly challenging, given that you have, your ij and k vectors right there, so it's not complicated multiplication, but, if you do choose to do that, then it is, it can be a little time consuming. This will definitely be more involved than your first assignment. First assignment was just, something to get you going into class the first week, so we didn't really have anything else to, go off of that on that first assignment, so. Good? I'm not going to say that because I had changed the size of those images. Okay, so keep in mind, tomorrow we will have our lab day. Again, I can help you with your code then. If you're having trouble with it, we can also go through and take a look at any other questions on the homework you might have and go from there. So far, how's the class looking for you?
Pretty good.
good. Because I suspect you probably paid more for this class than what you have on your other classes, and I wanna make sure it's worthwhile, so. Okay, so with that, we'll stick a fork in it for today.